Hello, my name is Dr. Rowena Christensen and I'm a medical educator at the University of Melbourne Medical School and also the founder and director of the Ad Astra Vita project. Today I would like to talk to you about commercial spaceflight, which is a rapidly emerging and growing area of human spaceflight endeavour. And I would like to talk about the yin and yang, the risks and the rewards, the tension that exists between the things that are just really exciting and really rewarding and maybe give us the biggest buzz we've ever had in our lives, but the inherent risks that are associated with that. And there's an old saying that if you fail to plan, you plan to fail, and thus it is with commercial spaceflight. For all of us who've ever dreamt of becoming an astronaut, space tourism, or perhaps, as it's more appropriately referred to, commercial spaceflight, may represent the best opportunity for us ever to experience spaceflight. Space tourism sounds very glamorous and super cool, but we do need to be cognizant of safety concerns. Unlike the famed Wild West of yore, there is some tension between entrepreneurship and regulation, and potential exists for mass casualty incidents both in the air and on the ground at spaceports or elsewhere. And we have to think about the individual because there is a potential human cost, and we need to balance the desire to fly with the question of, should you fly? Are you fit to fly? So today I'm going to be talking about parabolic flights and suborbital and orbital commercial spaceflight opportunities and ideas. You may well have heard of parabolic flights, sometimes colloquially referred to as the vomit comet. These might be reasonably accessible from a financial point of view, as the cost is around €6,000 or $10,000 Australian. And for this, you get a 2.5-hour journey with a total of about 5 minutes of weightlessness. And this occurs in 20-second bursts. So as you see from this diagram here, the aeroplane goes up very steeply. And during this phase, you experience hypergravity of up to 1.8 G. And then it levels off and takes quite a steep dive. So the aeroplane and the people in it experience freefall conditions, and as a result of that freefall, the participants have a feeling of weightlessness. Unfortunately, the health risks, which include fatigue, trauma and motion sickness, are only experienced by around 10% of participants. The next thing that I'm going to talk to you about is high altitude ballooning, and I'm going to show you 3 examples of this. However, the principles are quite similar. We're talking about ginormous balloons with a capsule hanging underneath them. They're going to go to a gliding altitude of around 19 miles or 31 kilometers. You'll have an extended experience at that altitude, and the cost is probably going to be a lot less than flying on Virgin Galactic or Blue Origin. And for instance, for $75,000 US, people will be able to experience the blackness of space above and will even be able to view the Earth's curvature. However, it's important to sound a note of caution for something that sounds relatively benign. And aviation safety expert Sasha Antonov has warned there is a need to implement space medicine to potential candidates, and necessary training must take place to account for special circumstances in space and possible equipment malfunction. So I want to point out 2 things to you here. The first is the need for medical screening of participants to make sure that they are actually fit to fly. And the second element is training, and we're not only talking about physiological training and customization, but also psychological, because for nearly all of the people traveling on these flights, this is going to be a once-in-a-lifetime experience. They will never have experienced anything like it before. And of course, circumstances are very different at that altitude than they are down here on Earth. And for some people, they could have an adverse reaction to suddenly being so far separated from Mother Earth. But of course, most people, again, will have flown on an aeroplane to a reasonably high altitude of 30,000 feet. But this is going to be vastly different. So it's possible that people might have unexpected reactions to having these experiences. And that can apply to this whole range of commercial spaceflight experiences which are being offered or proposed. And it's also really important to think about equipment malfunction, that people know how to handle themselves in emergency. If something happens, they know how to evacuate themselves safely or to put themselves in as safe as possible a position. Our next example is called Spaceflight Neptune, and this will operate on a similar principle. It'll be a total of a 6-hour flight with 2 hours floating around at the maximum altitude. Each ticket will be slightly more expensive at US $125,000, and they're already sold out for 2024, which is when launch is set to happen. However, the people behind this company do have an altruistic view. They would like average people also to have access to space, which has previously been limited to astronauts alone. And there's a lovely quote: "Space Perspective wants more people to experience the life-changing views from space that to date have only been accessible to astronauts, making it possible by applying flight technology also used extensively by NASA for many years." And there's also a third example which has only popped up relatively recently. It is also planning to launch in 2024, also offering a ride of 6 to 8 hours, also offering 30,000 meters and being able to see both the blackness of space and the curvature of the Earth. However, this one is a little bit different in that it plans to land under a parasail on the ground, whereas the previous one I showed you is planning to have a water landing. But the key difference with this particular company is that they are planning to offer an overall experience of about 5 days, which will be spent in and around sites of natural beauty and cultural and historical significance. And if you have a look at the publicity material, they're actually talking about a number of very significant sites all around the world, including Australia, Egypt, where the Great Pyramids are, Norway, America, plus a couple of others. But probably the other key difference is that they are selling their seats for around US $50,000, which is a lot less than any other space tourism experience. And they're also quite confident that the ride to the stratosphere is going to be smooth and gentle enough to accommodate people of widely varying ages and fitness levels. As well as high-altitude balloons, there are various proposals for hypersonic and supersonic aircraft. These would also cruise at about 30 kilometers high and have speeds up to Mach 5 times the speed of sound, which would enable you to cross the Atlantic Ocean in just 2 hours and the Pacific in 3, which would be quite amazing for those of us who live in places like Australia, where We have to undertake very long haul flights to get anywhere. And once again, for the passengers, their experience would include viewing the Earth's curvature at the horizon and the blackness of space above. It's worth noting that even though 100 kilometres is technically the edge of space, the so-called Kármán line, the air is too thin up there for conventional aircraft to operate. Now we'll have a bit of a look at the big players in the industry. Virgin Galactic had its first crewed flight of Spaceship 2 on the 11th of July this year. So that was successful. And once commercial flights begin, passengers will get a flight to between 80 and 110 kilometres in altitude and about 5 minutes of zero gravity or microgravity weightlessness plus a view of the curved Earth below. The acceleration forces are not insignificant, about 3.5 g on ascent, and the flight plan involves a dynamic glide back to Earth, and from the safety point of view, there'll be 2 pilots on board. It was reported in August that Virgin Galactic is going to resume sales and begin revenue flights in 2022, starting at US $450,000 a seat. And apparently consumers will get a choice of 3 options for space flights: a single seat, a multi-seat package, and a full flight buyout. And it'll also offer tickets to the people who've put down a deposit, and there's about 1,000 people on the waiting list. You can imagine that if it's just taking a few people at a time, how many flights it's going to take even to get through the backlog of people who've already indicated an interest. Now we'll move on to looking at Blue Origin. And on their website, they have this graphic, the one on the left that says compare the New Shepard experience, that compares them with Virgin Galactic. And Blue Origin claims to have a number of advantages in that it definitely flies above the Kármán line, that it uses a rocket rather than an aeroplane. It has the biggest windows in space. It has an escape system. It has minimal impact on the ozone layer, which is indeed something which is attractive in the current climate emergency. And it has a stronger flight history. And the graphic on the right-hand side shows the flight profile. So far, Blue Origin has actually had 2 successful flights. Their capsule takes up to 6 people. Their rocket is reusable, but on the negative side, there's no pilot on board. It's a total of a 10-minute flight with over 3 g of acceleration for 150 seconds and then a few minutes of weightlessness. It has a parachute landing in the desert as opposed to a gentle glide. And the cost of a seat, according to recent reporting, is US $28 million, so considerably more than what the quoted price for Virgin Galactic is at the moment. And on these 2 flights, so far, they've had the youngest person and the oldest person ever to fly to the edge of space, including, of course, the legendary William Shatner, Captain Kirk of Star Trek fame. And this issue about the Kármán line is quite an interesting one, because the FAA actually has a guidance as to who is entitled to commercial space astronaut wings, and you need to have demonstrated flight beyond 50 miles or 80.5 kilometres above the surface of the Earth as a flight crew. However, there's a problem for somebody who's just a space tourist, because you need to be able to demonstrate activities during the flight that were essential to public safety or contributed to human spaceflight safety. Recently, we've also had the successful Inspiration 4 3-day orbital mission, which occurred in September. And something that was particularly remarkable about that mission is that we had the first person who had some kind of prosthesis to fly in space. Now, moving on to orbital flight, NASA has opened up the International Space Station to short-duration private astronaut missions of up to 30 days in duration. And the idea is that these missions will use one of the US spacecraft developed under NASA's Commercial Crew Program, such as SpaceX, for instance. It'll be up to the commercial entity developing each mission to determine the crew composition and ensure that private astronauts meet NASA's medical standards and the training and certification procedures for International Space Station crew members. So we have to assume that that is going to be more onerous than the requirements might be to fly on a Virgin Galactic or Blue Origin flight. And according to reporting, NASA will charge about US $35,000 a night for each paying customer on top of the commercial charge for rocket flights and so on. There is already one mission slated which has been organised by Axiom Space, and it's history's first private ISS crew. And this is slated to take place in January 2022, and there's been various publicity out about the training that these people have been undertaking. There's also an interesting story on the Russian side. Between 2001 and 2009, Russia had a program which allowed private people like Denis Tito to fly into orbit and visit the International Space Station. However, there was quite a hefty price tag of between $20 and $40 million US. There's a company called Space Adventures. You can visit their website, which has organised 8 private citizens who have flown on the Soyuz to the ISS. It's offering an opportunity for 2 private astronauts to go to the ISS in 2023, and a spacewalk is planned for one of the lucky tourists, which would be quite an amazing experience for someone who's not a professional astronaut. It's also been reported that Japanese billionaire Yusaku Maezawa, who may be known to some of you through the Dear Moon project, is planning to fly to the International Space Station on the Soyuz in December of this year, together with his production assistant and an experienced cosmonaut. And apparently they will be undertaking a spaceflight of 12 days duration. And they've been undergoing spaceflight training at the Yuri Gagarin Cosmonaut Training Center in Star City, Russia. And he's been quoted as saying, "I'm so curious, what's life like in space? So I'm planning to find out on my own and share with the world on my YouTube channel." And his trip is also being organised by Space Adventures. Something even more interesting is that very recently we had 3 people go to the International Space Station by the Soyuz to make a movie in space, which is apparently called The Challenge, and it involved a veteran cosmonaut, an actress and a film director who spent 12 days flying above Earth to make a feature-length production. They also had to undergo 3 months of rigorous training. And the plot involves a cosmonaut who suffers a cardiac arrest during a spacewalk, and although he survives, he'll require surgery to ensure that he can handle the Soyuz return to Earth. A female cardiac surgeon has to be sent to the ISS to perform the procedure, with only a few weeks to prepare for the trip. And hopefully that will come out with subtitles, so all of us who don't speak Russian will be able to enjoy it. But it's really a very interesting concept of this kind of activity occurring on the International Space Station. And previously there had been chatter about Tom Cruise making a movie in space on the International Space Station. So it sounds like the Russians might have won that particular space race. The International Space Station is not designed to last forever, so there are a number of proposals of private space stations which will be able to step into the breach and continue to be used for a combination of research and also commercial spaceflight / tourism activity. And one which is actually underway in a concrete way is the Axiom Space Station. It's designed to orbit 250 miles above the Earth and to be a commercial laboratory and residential infrastructure that will serve as a home to microgravity experiments, critical space environment materials testing, and private and professional astronauts alike. Very recently, there's also been a proposal come out for what is called the orbital reef, which is a concept of blue origin and also being touted as a potential successor to the International Space Station, which is anticipated to be sunsetted sometime between 2028 and 2030. And this particular mixed-use business park would hold up to about 10 people, as well as being capable of exotic hospitality for space tourists. And it's designed to have almost as much habitable volume as the International Space Station. So that will be another watch this space concept. There's also been a recent proposal for a star lab, and that plans to be operational by 2027, and it's designed to be crewed by up to 4 astronauts, with about a third of the volume of the ISS. China is also building its own space station, the Tiangong, because China and the USA are not currently permitted to have cooperation on space activities such as America has with other nations on the International Space Station. So the Chinese decided to be practical about this and build their own, and they've started building the first module through the launch which occurred back in June of this year. And it's anticipated that this space station will also be used for both research and professional astronauts and potentially private astronauts or space tourism as well. There have also been a number of proposals for space hotels over the last couple of years, and they're just a couple of examples here. There was the Aurora Space Station, which was planning to launch this year and be operational by next year, and also Bigelow Aerospace, which did attach a prototype habitat to the ISS in 2016, and they do plan to build on this and build the first components of an orbital space hotel. However, those two proposals have not seemed to make a lot of progress. Also, more interestingly perhaps, there has been a proposal for a rotating space station similar to the absolutely iconic image from 2001, A Space Odyssey. And this space station was proposed to have artificial gravity similar to the Moon, which is 1/6 of Earth's gravity. And there are just a few quite inspirational images there. However, this appears to have been overtaken and rebadged. So it's now no longer the Von Braun, it's the Voyager station. and the opening date has been moved out to 2027. However, it's designed to have quite a large capacity of 280 guests and 112 staff, to have all sorts of recreational facilities. And once again, the initial proposal is for moon level gravity, about a sixth of the Earth, but they're quite aspirational, and they are hoping eventually to have Mars level, which is approximately a third of the Earth's gravity, and eventually to replicate Earth gravity. So there's a long way to go, and it's probably another example of watch this space. Now we're going to move on to looking at the more challenging side of commercial spaceflight. And I'd like to start with just prompting you to think about the tension which exists between our needs here on Earth and the research opportunities that commercial spaceflight can provide. And this is straying a bit into the realm of ethics, but it's certainly something worth thinking about. In October of this year, Prince William of the British royal family was highly critical of the billionaires who are focused on space tourism, saying they should instead be investing more time and money in saving the Earth. He said, "We need some of the world's greatest brains and minds fixed on trying to repair this planet, not trying to find the next place to go and live." And you can understand that comment in the context of the current climate emergency. He further emphasised his desire to ensure that his own children and future generations will not have to worry about repairing the Earth, adding it would be an absolute disaster if his son, Prince George, were to be talking about saving the planet in 30 years' time. And I have seen other commentary when you're thinking about all the cost and the time and effort that goes into space tourism, about all the problems here on Earth, the people who don't have clean running water, people who are living in poverty, people who are living in refugee camps. And so we have to be careful not to fall asleep at the wheel with our excitement about space tourism and turn our backs on all the incredibly challenging problems that we still face here on Earth. And I'm just going to quickly go through a few slides where we look at the flip side. We look at the ability of these suborbital flights to carry research and for research to be carried out on them. So Virgin Galactic has announced one partnership with the International Institute of Astronautical Sciences to conduct a dedicated research flight for experiments exploring new healthcare technologies. And also, really excitingly, TRISH, the Translational Research Institute for Space Health, SpaceX, and the Inspiration 4 mission have partnered to carry out a number of research projects. This included in-flight blood and saliva analysis, medical imaging using the Butterfly IQ ultrasound probe, which will literally fit into the palm of your hand, and looking at a number of parameters pre and post-flight. Really interesting, they used an Apple Watch to monitor and collect a wide range of data, including ECG, movement, sleep, heart rate and rhythm, blood oxygen saturation, camera noise and light intensity. Also conducted neurocognitive performance tests and looked at re-adaptation to gravity after spaceflight through sensory motor testing. And one of the most interesting things to come out of this is the development of a standard human subject research protocol for medical data research data, environmental data, biosample collection, ingestion and release, a single subject consent form, compliance with US and international privacy laws, and the provision of data and biosamples to spaceflight providers, NASA and external investigators. And it would be spaceflight provider agnostic in that it would be applicable to any of the commercial spaceflight providers. And all of this information would be collected in what's going to be called the Hermes database, the Commercial Spaceflight Human Research Database Repository. Now we're going to spend a little bit of time looking at risks and thinking about preparing to avoid disaster and enhance safety. First off, we have to be aware of the potential for disaster. With any type of human exploration, and we've seen this throughout history, there are risks as we push boundaries, and there are inevitably mishaps and fatalities as a result. And space exploration is no exception. There have been a number of major disasters with tragic loss of life. And the 2014 Virgin Galactic Spaceship 2 Enterprise prototype crash was the latest casualty. It's interesting to take a look at the US human spaceflight safety record. Fortunately, there's only been a small number of catastrophic failures or people who have been seriously injured or died. If we convert those to a percentage risk for orbital flights, it's 1.82%, for sub-orbital 0.95%, and overall 1.33%. And it's useful to put that into context by contrasting it with the odds of a typical American dying from a motor vehicle crash, which is 1 in 114 or 0.88%. And fortunately, air incidents are much, much rarer. And this latest figure was 0.01%. There's an increasing number of spaceports all around the world. And of course, the more spaceports you have, the more possibility that things are going to go wrong, whether that is a crewed launch or a non-crewed launch. Spaceports are going to be busy places. They'll employ a large number of people. There'll be a focused geographical area. And as well as the people who work there, it's quite likely that people will gather to watch launches and landings and to be the cheer squad for their loved ones taking a flight to the edge of space. And if you've seen any vision of when William Shatner and his crewmates came back recently on the Blue Origin flight, there was a huge crowd of people who gathered around. As is the case at airports, you're going to have large amounts of flammable fuels and other chemicals. And so there's an ongoing risk of mass casualty incidents resulting from the combination of rocketry, fuel, spacecraft, and mass gatherings. It's going to be very important to think about spaceport emergency management plans. Most spaceports will be in remote areas. In fact, they probably are going to have to be in remote areas that are far from major hospitals and trauma centres. And their location is probably going to be related to some degree to the risk that they represent. And spaceport medical directors will need emergency response plans, and that will need to include emergency management plans, and that should include the possibility of mass casualty incidents. It's not something anybody likes to think about happening, but it's like the old saying, if you fail to prepare, you are preparing to fail. And there's a wide range of things that you need to think about. Next, I'd like to move on to some of the factors that are involved in making it safe. And the first thing is going to be the spacecraft design. And we're going to need a spacecraft that can withstand both high G-forces on ascent and descent and the external environment. Has to be able to launch, fly and land safely, and those are all dangerous phases of flight. It has to be able to protect the occupants from the environmental hazards outside, and they're going to be facing extreme high altitude, low barometric pressure, extreme cold and a virtual absence of oxygen. So all of that is fairly threatening to human life. And ideally, you're going to have highly trained space pilots who will get passengers there and back safely. But it's interesting to note that while Virgin Galactic has 2 pilots on board, which is a good degree of redundancy, there are no pilots on the Blue Origin missions. Astronauts typically spend years training for a mission. And in his book, Endurance, NASA astronaut Scott Kelly mentions he had been training since 1999 in one way or another for his 2015 to 16 year-long mission to the International Space Station. So it would be quite reasonable to hope and expect that space pilots would have had a long apprenticeship. So the next thing to think about is the passengers, and they will need to be suitably trained, attired and protected from the environment. They also need to be constitutionally capable of coping with the anxiety and psychological stress of spaceflight, in addition to the physiological stressors such as the increased G-forces. As well as providing a pressurized cabin with supplemental oxygen, risk mitigation strategies might include passengers wearing body-hugging pressure suits for protection against the effects of sudden depressurization and hypoxia. The next issue to think about is training specifically. And it's a really interesting situation at the moment because we have this tension between the entrepreneurial drive and lagging behind government regulation. So at the moment, it's pretty much up to the operators as to what specific training is required. But we would hope that that would include informed consent, which is required by the FAA, and emergency response training and physiological familiarization. However, the FAA requirements are pretty minimalistic. The section on spaceflight participant training merely says, an operator must train each spaceflight participant before flight on how to respond to emergency situations, including smoke, fire, loss of cabin pressure, and emergency exit. However, if you actually sit down with a large cup of coffee to read through the regulations, the section on the operator informing spaceflight participant of risk is much more extensive. There isn't a great deal of information available about what training is actually being offered by the 2 main spaceflight providers at this moment in time. However, I was able to find on the Virgin Galactic website that they will be offering a 3-day pre-flight training program to ensure each spaceflight participant is mentally and physically prepared for microgravity and periods of high acceleration, and they will have aerospace medical experts on hand. Blue Origin was reported to have provided 14 hours of comprehensive training over 2 days and stressing the point to be compliant with FAA regulations. There was a Blue Origin trainer for each group and bonding with their crewmates at an astronaut village. And the training does sound quite reasonable in terms of knowing the vehicle, knowing how to deal with problems, knowing how to get out of the vehicle in a hurry. It sounds like they also had quite a good number of mission rehearsals and different scenarios, and they even had to take a final exam. And the reporting said that this included both a classroom and a simulator component, as well as time on the launch pad to be familiarised with the capsule, the facilities and the broader team. So that actually sounds like a really good start. As a private citizen, you can also undertake training at the NASA Center in the USA, and they offer a variety of spaceflight training programs, including suborbital and orbital participant training, and also suborbital and orbital refresher training, and in addition, advanced human spaceflight training. All of these courses are only 1 to 2 days, but they do include simulator and centrifuge training. And the advanced course also offers altitude chamber training. And the value of this is that you can simulate taking people to altitude, and you can also vary the amount of oxygen in the air. So you can expose people to relative degrees of hypoxia, and they can learn to recognize the symptoms of hypoxia and how to react to that in an emergency situation. But trainees do require an FAA Class 3 medical certificate or equivalent, and to be in good health and capable of taking part in all activities. And something I was personally excited to find out about is the Blue Abyss project, which will be opening in Cornwall in the UK, probably in 2023. And this is going to be a huge facility with a neutral buoyancy pool similar to the one that you might have seen in NASA and Soviet facilities. They'll also be offering parabolic flight, centrifuge training, hypo and hyperbaric chambers, microgravity simulation, together with on-site health professionals, the world's biggest 50-metre deep pool and environmental research centre. And the pool will be customisable to accommodate a range of diving, marine and space-related projects. So it's going to be very flexible, and I think, knowing a number of the people involved with it, it's going to be a very, very exciting project with a lot of potential. Now, you might remember that I mentioned earlier that it's not just all about the physiological side. We do also need to think about the psychological side and adequately equipping people from a mental and psychological point of view for going into space. And Dr. Mindy Howard has actually established a company called Inner Space Training that specifically provides this sort of expedition training. And just harking back to Parabolic flight, where we started this whole journey, it's actually quite interesting to have a look at the medical requirements on the Novaspace France website. They offer some of the zero-G flights, and they have information freely available so people can make an initial assessment as to whether they might be medically fit. They mention some contraindications, and then they tell people what they need to do. They need to go and have a medical screening by either their general practitioner or a specialised aerospace medicine doctor, and they also need to have had a recent ECG. And if you actually sit down again with another large cup of coffee and read through the medical document, it's really quite detailed. And for anybody thinking about the issues involved in medical screening of commercial spaceflight participants, I can definitely recommend this because it provides a lot of insight into the sort of things that should be considered. And this question of medical screening guidelines for commercial spaceflight participants has actually been under consideration for longer than you might think. The Aerospace Medical Association published some guidelines back in 2001 to 2, the FAA in 2006, and the International Academy of Aeronautics has had 2 tranches of this. And at the moment, from reading between the lines, requirements may vary between spaceflight providers, But as for the Air Zero G parabolic flights, it's likely passengers will need to visit a doctor trained in aerospace medicine or a GP who has good insight into the field of aerospace medicine for a pre-flight medical and an ECG, and to have a favourable assessment of their response to pre-flight training. Now, if you pick up your third large cup of coffee, it's good to have a read of the FAA guidelines, and these distinguish between the suborbital and orbital flights in terms of the basic minimum requirements that are set out. And if the suborbital G-load profile could exceed plus 3 GZ, then the orbital aerospace flight guidelines apply, and it's strongly arguable that this would apply to both Virgin Galactic and Blue Origin flights. So this requires a more comprehensive medical questionnaire, physical examination, laboratory testing, that this should only last for a period of 1 year, and an updated history and abbreviated examination is needed 2 weeks prior to flight to ensure no significant medical changes have occurred. And the FAA also provides a list of medical conditions which may contraindicate passenger participation in suborbital or orbital flights. It's good to know that people with pre-existing conditions will not necessarily be excluded, but they need to be able to handle themselves in an emergency. One wild card, of course, is there's no way of predicting who will develop space motion sickness, which could be nausea and or vomiting when exposed to microgravity. And this is due to the disorientation of the vestibular or balance systems in the inner ear when it loses all its familiar inputs. So this doesn't have to be a deal breaker. Quite a few astronauts suffer from space motion sickness, but you need to have a good management strategy because, as you can imagine, it could be hazardous for everyone in the cabin. There's still a lot of unknowns. Yes, there are. And to some extent, the jury is out until meaningful data on commercial spaceflight begins to be collected. And this is going to be part of the plus side that I talked about earlier, that there actually is going to be the potential for research to be carried out, not only biological experiments, but also on human subjects, as was well demonstrated by the Inspiration 4 mission. However, it's good to know that the results of 3 studies commissioned by the FAA to investigate the ability of laypersons to tolerate the stresses of simulated suborbital spaceflights have been very encouraging. They had study participants from 19 to 89 years with a large variety of common stable medical conditions, and they were able to tolerate the acceleration profiles in a centrifuge physiologically without difficulty. However, and this is harking back to my earlier point about unpredictable reactions, 6% chose to stop the centrifuge exposure, most often because of anxiety or motion sickness, and 14% of participants, which is not insignificant, had unsafe or potentially problematic behaviours. This is definitely an evolving area, and it will probably continue to evolve quite rapidly. There was a recent publication of a review on medical guidelines for suborbital commercial spaceflight, and they made a number of recommendations. That medical guidelines are needed as commercial suborbital flight becomes more accessible, that spaceflight participants should be risk stratified and mitigated prior to flight, that training programs can mitigate risk for spaceflight participants, that medical emergencies will occur in flight and basic in-flight care is recommended, and in-flight biomonitoring can address gaps in our knowledge of suborbital physiology. So, in conclusion, ongoing dialogue is needed regarding medical screening and training guidelines for commercial spaceflight participants, and this is likely to be informed by experience and data collection. And interestingly, the Aerospace Medical Association has recently established a new committee on commercial spaceflight, so it's definitely going to be a watch this area closely from that point of view. We need to recognise that there is a potential for disaster, and the burden of the risk of unexpected deaths or adverse medical events during commercial spaceflight falls on individuals and their loved ones, with potential commercial fallout. For instance, if somebody dies during a Virgin Galactic flight or a Blue Origin flight. And there will be a permanent risk, a risk that's never going to go away completely, of spacecraft and or spaceport disasters. So robust risk mitigation and response strategies will be required. Risk is something we never should be, nor can be, complacent about. To quote the Spanish philosopher George Santayana, "Those who cannot remember the past are condemned to repeat it." Thank you very much for your attention. And if you have any questions, I can be contacted via the Ad Astra Vita project website, QR code on this page. And I'd also like to recommend the Ad Astra Vita project website to you as a very comprehensive portal for resources on space medicine, space health, and medicine in extreme environments. On the last couple of slides, for anybody who wants to look at it in more detail, I have the references and image credits.